Have you ever looked up at the night sky and seen that steady reddish dot among the twinkling stars? That's Mars. For as long as we have been looking up, it has captured our imagination. But why? Out of all the countless objects in the cosmos, are we so focused on Mars? The answer is both simple and profound. Mars is close enough to reach, similar enough to Earth to maybe, just maybe, support us. Different enough to hold the answers. It is a planetary neighbor that feels tantalizingly within our grasp. The follow-up question is just as important. Why now? The technology, once the stuff of science fiction, is rapidly becoming reality. We are witnessing a renaissance in spaceflight, rockets more powerful and reusable than ever before. This is not just one country's effort anymore. It is a global convergence of NASA, SpaceX, and other international partners. Investment and collaboration have reached critical mass, and our probes and rovers are sending back tantalizing clues. Riverbeds, frozen water ice, and the chemical building blocks for life. For the first time, we are truly able to answer the call. Before we ever set foot on Martian soil, we send our scouts. These are our robotic explorers, the rovers and landers, that have been our proxies on the Red Planet for decades. Think of them as the advance team, mapping the terrain, testing the environment, and identifying dangers long before humans. Missions like Perseverance are sophisticated mobile laboratories. They drill, cache samples, and prepare for future sample return. This is geology on another world, a crucial first step. Instruments taste the air, 95% carbon dioxide, far too thin to breathe. Cameras reveal rusty dust, towering volcanoes, and canyons that dwarf the Grand Canyon. Curiosity reads rock layers like pages, confirming ancient habitability. They help find safe landing sites and locate vital water ice. That ice becomes drinking water, breathable oxygen, and even rocket fuel. Radiation, temperature swings, every data point guides suit and habitat design. We cannot build a house on Mars without surveying the land, and the robots are doing it. The first explorers of a new world are robots. They are drawing the map that will guide the first Martian boots. Arriving on Mars is only half the battle. The real challenge begins when we step outside. The Martian environment is incredibly hostile to human life. The air is the first problem, or rather, the lack of it. Mars's atmosphere is about 100 times thinner and mostly carbon dioxide. Without oxygen, an unprotected human would lose consciousness in under a minute. Early explorers will live in sealed habitats and venture out only in pressurized suits. It is like living at the bottom of the ocean, with even more dangers. Water exists as ice, not rivers and lakes. We must mine, extract, melt, and purify it. Every single drop will be precious. Ultra-efficient recycling will reclaim moisture from air, wastewater, even breath. With little magnetic field, radiation threatens long-term health. Homes must be castles, thick walls, preferably buried under Martian soil. Nights can plunge to 125 degrees Celsius. Reliable power will mix advanced solar with small nuclear reactors. Sterile, toxic soil means food grows in enclosed, climate-controlled farms. Hydroponic and aeroponic systems will manage soil, water, and nutrients. Imagining a future on Mars is not a single leap, but careful steps. The journey will unfold over decades, each phase building on the last. Next 10 years, robotic preparation and tech demos. We will prove oxygen can be made from the Martian atmosphere and water from soil. Robotic sample return brings pristine Mars pieces to Earth. In 20 years, first boots, short stay, flags, and footprints-style missions. They will land safely, live in a pre-deployed home, run key experiments, and launch back to Earth. Ultimate test pilots, verifying systems, suits, and habitats in Mars reality. Success paves the way for longer missions. By the 2070s, a small permanent outpost is plausible. Not a city, a self-sufficient research base with a dozen or two crew. They will study, expand habitats, grow food, and start small-scale mining and manufacturing. Ambitious, not fantasy, grounded in today's progress. From robots, to short stays, to a true settlement, a logical progression, a tiny flicker of human life burning on the cold red plains. The ultimate goal of going to Mars is not to abandon Earth, but to enrich it. Pursuing this audacious goal creates benefits that ripple to everyone. Scientifically, Mars is a treasure, a planetary time capsule. Finding past or present life would redefine biology and our place in the cosmos. Why Mars lost its water informs climate science, helping protect Earth. Keeping humans alive on Mars demands new technologies. Breakthroughs in life support, water reuse, and oxygen generation help water-scarce regions on Earth. Closed-loop farming grows more food with less water and space. New materials, advanced robotics, AI, and telemedicine will spark industries and jobs. Perhaps most powerful is inspiration. Great challenges bring out our best. As Apollo did for STEM, Mars will ignite today's children. It gives us a shared, long-term goal that transcends borders and politics. Aiming for Mars forces us to think generationally, to work together, and to dream big. Living on Mars is a plan to improve life on Earth. We must support missions, fund research, and educate the next explorers. Mars is difficult and dangerous, but together we can reach the next horizon.